Have you ever pondered what happened at the very dawn of time? It's a question that's been boggling minds since humans first looked up at the stars. A question so profound it makes your head spin just thinking about it. You see, the nature of time is one of the greatest enigmas of the universe. As we journey back through the vast expanses of history, we hit a wall when we reach about 13.8 billion years. Before that point, we simply don't know what happened. This is where the Big Bang Theory comes into play. It's not just about a massive explosion that scattered galaxies across the cosmos. No, it's much more than that. This theory suggests that the very fabric of time and space itself came into existence at that moment. It's a concept so mind-bending, it's like trying to imagine a new color. So what if we told you that time and space themselves started with a Big Bang? Picture this. An incredibly hot, dense point smaller than an atomic particle. This was our universe about 13 billion years ago. It's hard to fathom, isn't it? A realm so compact it was virtually invisible. Yet it contained the raw materials for everything that exists today. Now, imagine this infinitesimal point beginning to expand. Not slowly, mind you, but at an unimaginable speed. This wasn't your regular explosion, it was an explosion of time, space, matter, and energy. This was the Big Bang, the mother of all fireworks. In less than a blink of an eye, the universe grew from this subatomic point to something billions of miles across. And it didn't stop there. It kept on expanding, creating galaxies, stars, planets, and eventually life as we know it. The Big Bang wasn't just a bang, it was the birth of time and space, the genesis of all existence. But how do we know this isn't just a fantastical story? Scientists don't just make wild guesses, they need evidence. When it comes to the Big Bang Theory, three main pieces of evidence provide solid support. First, let's talk about the expansion of the universe. Almost a century ago, astronomer Edwin Hubble made an exciting discovery. He found that galaxies were moving away from us, and the farther they were, the faster they were moving. This observation suggested that the universe is expanding. And if we rewind this expansion, we reach a point where everything was packed into a single, dense, hot point, the Big Bang. Next, we have the abundance of light elements. When we look at the universe, we find a lot of hydrogen and helium. These elements are thought to have formed in the hot, dense conditions of the early universe just moments after the Big Bang. The proportions of these elements match the predictions of the Big Bang Theory remarkably well. Finally, there's the cosmic microwave background radiation. This is a faint glow of heat left over from the Big Bang that fills the universe. It's like the echo of the Big Bang, still detectable today. When this radiation was discovered in the mid-20th century, it provided a major boost to the Big Bang Theory. These clues from the cosmos tell us that the Big Bang Theory might just be the real deal. But the Big Bang Theory isn't perfect. It leaves us with some burning questions. As much as it paints a vivid picture of our universe's fiery birth, the Big Bang Theory doesn't have all the answers. It gives us a grand explosion, a cosmic light show, to start the clock of time. Yet it doesn't tell us what lit the fuse, what existed before that monumental bang. Unfortunately, the Big Bang Theory remains mum on this. Moreover, it doesn't solve the enigma of dark matter and dark energy. These elusive entities make up 95% of our universe, yet we know very little about them. Dark matter, the invisible glue holding galaxies together, and dark energy, the mysterious force accelerating the universe's expansion, are both cosmic conundrums the Big Bang Theory doesn't unravel. These unanswered questions don't undermine the Big Bang Theory. Instead, they spur us on, fueling our curiosity and pushing us to probe deeper. They remind us that science is a journey, not a destination. It's about constantly questioning, exploring, and learning. So, while the Big Bang Theory might not be the final word on our universe's genesis, it's a compelling starting point. It sets the stage for a universe full of wonder, mystery, and endless possibilities. So the next time you gaze at the stars, remember, you're looking at the aftermath of a colossal explosion that started it all. Isn't that a bang to remember?